Invention is the most important product of man's creative brain. Nikola Tesla. By 1975, Richard Davis had been shot in the chest 192 times. It wasn't the result of bad luck or criminal activity. Each bullet came from his own gun. Every shot was part of a demonstration to promote his invention, the bulletproof vest. Davis didn't trust charts or technical explanations to convince people. He believed they needed something unforgettable. So, after testing his vests on dummies, he began shooting himself to prove the vest worked. It was reckless, dangerous, and highly effective. Audiences gasped as he fired at point-blank range, then watched him walk away with only minor bruises and scratches. The sight left them stunned. How could such a lightweight, flexible vest stop a speeding bullet? The secret lay in a revolutionary material called Kevlar. It was invented a decade earlier by chemist Stephanie Kwolek. In the 1960s, Kwolek worked at DuPont, the company that had revolutionized textiles with nylon, the world's first synthetic fiber. Now, the company wanted something stronger. They were racing to develop lightweight, durable fibers for high-performance tires. Kwolek's task was to create a polymer strong enough to handle these demands. Polymers are long chains of repeating molecular units called monomers. Some are made from identical monomers strung together like beads. Others alternate different molecules in intricate patterns. The way these molecules bond determines the polymer's strength, flexibility, and other properties. Kwolek spent months experimenting with different chemical combinations. Most results were predictable, but one batch was odd. The liquid was cloudy, thin, and unappealing, completely unlike the usual transparent solutions. Lab technicians considered discarding it, but Kwolek insisted on running it through a spinneret, the machine that turns liquid polymers into fibers. The result defied expectations. The fibers were light, flexible, and remarkably tough. Tests revealed they were stronger than steel, yet could be woven into soft, breathable fabric. Kwolek had created a liquid crystal polymer, the first of its kind. Its name, Kevlar. At the molecular level, Kevlar consists of 1,4-phenylene-diamine and terephthalonyl chloride. These chemicals form parallel molecular chains that remain tightly aligned. The result is a structure that behaves in surprising ways. When pressure is applied, the chains shift like a fluid, dispersing energy across the material. But hydrogen bonds between molecules keep the fibers from unraveling. To understand why Kevlar is so effective, it helps to compare it to other materials. Metals like steel are incredibly strong due to their metallic bonds. In metal, electrons move freely between atoms, creating a dense, resilient structure. This electron sharing makes steel difficult to penetrate. A bullet hitting a steel plate meets tightly interlinked atoms that absorb the impact and stop the projectile. Wood, on the other hand, lacks these properties. Its fibers are held together by cellulose bonds, which are much weaker. A bullet easily shatters wooden surfaces, leaving splinters behind. Kevlar occupies a middle ground. Its hydrogen bonds are weaker than metal's atomic bonds, but far stronger than wood's cellulose structure. The material's tightly woven fibers create a net that disperses energy. So, what happens when a bullet hits Kevlar? The bullet's kinetic energy transfers into the fabric. The fibers bend, stretch, and shift, but the hydrogen bonds resist breaking. Energy is dispersed throughout the material. This slows the bullet dramatically, often stopping it before it penetrates the fabric. Even if a bullet does pierce Kevlar, its velocity is reduced to the point where it causes less damage to the body beneath. However, Kevlar isn't indestructible. Over time, exposure to UV light degrades the fibers. The material also weakens in acidic environments, making it unsuitable for certain industrial applications. And even when a vest stops a bullet, the impact leaves deep bruising and blunt trauma injuries. Despite these limitations, Kevlar's usefulness extends far beyond bulletproof vests. It reinforces car tires, providing durability and performance at high speeds. It strengthens helmets and protective gear, protecting soldiers and athletes alike. In space exploration, Kevlar lines spacecraft exteriors to guard against micrometeorite impacts. Even audio equipment uses Kevlar speaker cones for their high efficiency and minimal distortion. Stephanie Kwolek never set out to create bulletproof fabric. Her focus was on stronger tires, yet her discovery revolutionized personal protection and material science. Her invention has saved thousands of lives. Richard Davis, with his 192 self-inflicted bullet wounds, proved that fact in the most dramatic way possible. For more videos, please like and subscribe.